Here it is, page 9, and we've only got one more graph left because we've eliminated all of the other ones as we used them. So let's take a look. The jelly bean challenge. We'll identify the independent quantity, the dependent quantity. We'll put that information with an appropriate scale and label on our graph, and then we'll talk about what the origin means. Mr. Wright judges the annual jelly bean challenge at the summer fair. And every year he encourages the citizens in his town to guess the number of jelly beans in that jar. He records all the possible guesses and the number of jelly beans that each guess was off by. So if you guess pretty close to the actual number, you should be low on this bouncing V-shaped absolute value graph. It looks like we've already been able to establish some stuff that's happening from reading it. The number of jelly beans that each guess was off by. Since the number of jelly beans that each guess was off by, that whole sentence uses both of the quantities. Quantity, we're talking dependent and independent. Then that means guess is the independent quantity. And number of jelly beans has to be dependent on that guess. So number of jelly beans I'm going to underline. Guess I'm going to circle as our independent and dependent. The guess and then the number of jelly beans off. Like, off by 2. So then that information is going to tell us that I'm going to put that on the graph. Our guess is our independent. And so guesses just go by I guess it's not like guessing amount, right? You're guessing the amount, not like this is your first guess. You're guessing 500. There is no information for us other than maybe going to the graphic and trying to count that, but that doesn't have to directly relate to it. Then the y-axis would be number of jelly beans off. What's the origin then? So the origin, like we've learned, has to be at 0, 0. And so our origin, 0, 0, would be if you guess 0, then you're off by 0. Of 0 beans is off by 0 beans. And that's not true because definitely our graph, if you guess 0, you're way off. There's a full jelly bean jar. So then you'd have to guess and be off by that amount. That's actually the total. The distance between guessing 0 and then the height of the graph right here is the total number of jelly beans in the jar. So that's kind of nice. And if you guess a number bigger than 0, guess, 1, well, no, you're wrong. But you're off from the total by the total minus 1. So then this graph should continue to shrink all the way down to the total number. I don't have a good scale because I make it up. I don't know there's 155 jelly beans in the jar. Totally unknown. That does it though, you guys. That continues or finishes our conversation on independent quantity, dependent quantity, how we can tell when the independent quantity exists, what is it about being independent that impacts our choice for the other quantity to depend on it. Thank you for watching, liking, commenting, and subscribing, and seeing all the way through this Activity 1. And I wish you the best as we work on Activity 2 and continue our journey in Algebra 1, Topic 1, Lesson 1. But we're doing the second activity, Activity 2. That's next. Stick around.